Okay, so we had just did in the last question in part 2 of finding the volume of solids, we did one around a vertical axis. And actually, this method I'm going to show you, the method of cylindrical shells, is great for when rotating around a vertical axis. Okay, in fact, I'm even going to show you doing one of method of cylindrical shells around a horizontal axis, and you can see how awkward that one is too, because horizontal, let's switch to the methods we learned in 1 and 2, and around vertical, let's use this method. Now, this works on 2 pi r times height, okay? Because what we're going to do is we're going to, if you remember, if you want to find the area of a side, right, you go like this, you take it out, and how do you find the area? You go 2 pi r times height. Okay, so what we're going to do is we're going to add all those sides up as we move in, and we'll add them together. Okay, so let me show you how this works. Okay, so this 2 pi r times our height. Okay, so use this method of cylindrical shells to find the volume of solid that results when the area bounded by y equals x squared plus 2. Okay, so let's kind of draw this out. Okay, so we have our x-axis and our y-axis and our x-axis. So here's our y, here's our x, and we're going to be rotating around the y-axis. Okay, it says we're rotating around here. Okay, and it's y equals negative x squared plus 2. Okay, so if you graph this, you get y equals negative x squared plus 2, and y equals 0. Here's y equals 0, here's y equals negative x squared plus 2. Okay, so you can see this one would be a tougher one to do using the methods we learned last day. So we first have to find out where these intersect, right? Because we want to find that when it's spinning. Okay, now, and the way that it works is I'm just going to take, see this here, really, really thin, and I'm going to spin it, right? And as it spins, okay, it is going to be making that shape. And if you keep adding up all those sides together, you get the volume. So then we'll do a little bigger one, right? And that'll come out here, right? And we'll just keep adding those up. Okay, so first of all, we want to find out where these intersect. So negative x squared plus x equals 0. X, I'm going to take that out. That is negative x plus 1 equals 0. So it will intersect at 0 and 1. Okay? So volume equals 2 pi. We're going to go from A to B of shell radius times shell height dx. Okay? And dx is like the depth. How thick is that little side going to be? And then volume is 2 pi, going from 0 to 1. Now, my radius is going to be from the distance to where we're going to that side. That's distance x. So that's x. Okay, and what is my height, or shell height? It's negative x squared plus x. And it's changing everywhere, that's why we need to find the integral. So v equals 2 pi 0 to 1, and we've got x, or negative x cubed plus x squared d of x. Volume would equal 2 pi, if I do the integral, that's negative 1/4 x to the 4 plus 1/3 x cubed, 0 to 1. Volume is 2 pi times negative 1/4 times 1 to the 4th plus 1/3 times 1 cubed minus 0. Volume will equal pi over 6. Okay, so that's just adding up all those little thin sides, which gives us the area, or volume, sorry, under the, so this again would be cube units. Okay. Let's do example 3. Or 2, sorry, example 2. We've got 4 examples today. So, use the method of cylindrical shells to find the volume of a solid that results when the region bounded by y equals negative x squared plus 2 and y equals 0 rotated about x equals 3, negative 3. So very similar question to before, right? We have our y, got our x. Okay, we've got this, y equals negative x squared plus x. But over here is x equals negative 3. We're going to rotate around here. So now, if I have a side in here, this is going to be my radius. So my radius is, now if we were looking from this way, do you see how I'm above? So I'm going to go minus c, just like I've always done before. So v equals 2 pi 0 to 1, x is my radius, right? So that's x minus negative 3 is how I will get my radius. And my height is still going to be negative x squared plus x. That's f of x minus g of x dx. Because my other one is 0, so this is f of x minus g of x. The g of x is 0, so that's why it's just f of x. Okay, so volume is 2 pi 0 to 1 x plus 3 times negative x squared plus x dx. Volume is 2 pi 0 to 1. If I multiply that all in, I get negative x cubed plus x squared minus 3x squared plus 3x d of x. Volume is 2 pi 0 to 1. Okay, it's negative x cubed minus 2x squared plus 3x dx. Now I can do my integral. Volume is 2 pi negative 1/4 x to the 4 minus 2/3 x cubed plus 3 over 2 x squared. Oops, I'm going to do square brackets there. Put 0 and 1. Volume is 2 pi negative 1/4 times 1 to the 4th minus 2/3 times 1 cubed plus 3 over 2 times 1 squared, all minus 0. And volume will be 7 pi over 6 units cubed. Okay. Now, let's do one in that we do have an f of x and a g of x, subtracting. Okay? And this, again, is rotated about the y-axis. Okay, again, for this one, we have to find out where they intersect. Okay, so anyway, this is 5x minus x squared equals 8 minus 5x plus x squared. Okay, if I get everything on the right, I'll get a 0 equals 8 minus 10x plus 2x squared. Okay, I can take out a 2 with 4 minus 5x plus x squared. 0 equals 2, and that's x minus 1 times x minus 4. So the intersects are at 1 and 4. Now you can see that on the diagram, but I just wanted to do it because I wanted to make sure that it was accurate. Okay, so for this one, now I can find my volume. Remember, I'm rotating around the y-axis, so v equals 2 pi a and b. X is going to be my radius, and f of x is the upper, minus g of x, that's the lower, dx. So volume is 2 pi 1 4 x. Now the upper was x times 5x, 5 minus x, minus the lower, which is 8 minus x times 5 minus x. A lot of fun math in this one. Okay. Now, so volume is 2 pi 1 4. We've got x times 5x squared minus 1, or 5x, sorry, minus 1x squared minus 8 plus 5x minus x squared dx. So the volume is 2 pi, and we're going 1 to 4 x times 10 x minus 2x squared minus 8 dx. Volume is 2 pi 1 and 4. Oh, no, I'm going to actually do the x in now. Sorry, yeah, 1 to 4. So that's 10x squared minus 2x cubed minus 8x dx. Now I'm going to do the integral. Volume is 2 pi 1 and 4. Oops, don't need that because I'm doing the integral. So that is 10 thirds x cubed minus 2 fourths, which is 1/2 x to the 4 minus 4 over 2 x squared, and that is 1 to 4. So volume is 2 pi, ooh, this is fun, 10 thirds times 4 cubed minus 1/2 times 4 to the 4th minus 4 times 4 to the 4, all minus 10 thirds times 1 to the 3 minus 1 half times 1 to the 4 minus 4 times 1 to the 4. Okay, and when you get that together, you get volume is 2 pi 64 over 3 minus negative 7 over 6. So volume equals 45 pi units cubed. Okay, last one. Now this one is one that I wouldn't recommend doing this way, but I just want you to see how it works. So use a method of cylindrical shells to find the volume of solid that results when the region bounded by x equals 0, y equals 2, and y equals square root x rotated about y equals 1. Okay, so let's get a drawing. Okay, the bell's going to be ringing soon here, so bear with me. Okay, so this is x equals 0. This is, oh, I got y equals 2 here. Oh no, what am I talking about? That's y equals negative 1. Y equals negative 1. That's what I'm going to rotate it about. Okay, but I got x equals 0, y equals 2. So that's right there. No, I guess that would be way too high if I... Okay, so let's say that's y equals 2. And y equals square root x. So that'll be something like that. Okay, y equals square root x. Okay, so we're going to rotate. So here's my, what I'm going to rotate around, and I'm going to use my shells. Okay, so this is going to be my radius, which you can see would be y, and then minus negative 1. So y plus 1 will be my radius. Okay, this is my axis of rotation. Okay, again, we want to look from here and pretend this is like, that's the bottom. We turn our graph, right? And we're going to be, right, bringing this around here. Right, that's going to be coming around. So now this one we have to get our into y into x. So this would be x will be y squared. Okay, if I square both sides. So volume is 2 pi, and we're going from a to b, y times f of y minus g of y dy. Okay, now our radius is y minus negative c, right, because we're on top of it. Oh no, that would be, yeah, that would be, so y plus 1, right? So we would have, we're going 0 to 2, right? Those are my y values I'm going to put in from 0 to 2. Okay, it's because we're starting at y is 0 and y is 2. And then y minus negative 1, or y plus 1. So we can just put that in there. You can see that as my radius.
Would you come to the office?
And y squared minus 0 dy. So volume is 2 pi, 0 to 2. Okay, if I multiply this in, y cubed plus y squared dy. Then volume is 2 pi. Okay, now I'm going to do my integral. That is y over 4 to the 4th plus y cubed over 3, going from 0 to 2. Volume equals 2 pi. Now I'm going to put in my 2. 2 to the 4 over 4 plus 2 cubed over 3. Okay, and well, minus 0. So volume will equal 2 pi actually I didn't figure that. I actually just figured out the answer. That would be 40 pi over 3 cubed units. Okay, so I don't recommend this way. This way is kind of confusing, right? Because we're used to when you rotate around a horizontal axis, we should use our volume of solids, okay? Because this one is a horizontal axis. Okay, and I guess even this one, maybe I wouldn't look at it from the bottom way. Maybe I would just look at it from this way, turning, right? And this is beneath it, right? So that's why I would go and do y minus -1, because that's our axis of rotation. And then you've got to convert everything to x equals. You've got to make sure you're putting in your y values of 0 and 2. So it is a much more difficult way of doing these, and I just wanted to do one so you could see how it worked, but I would use my volume of solids if it was me to do this one. Okay? So there is your assignment. Okay, you can see that all at one time there. You can now take this and do it, and then you can check your answers on my website.